Hello ladies and gentlemen, welcome to Weather Talks. Today I'm going to briefly introduce a recently published article entitled Increasing Risk of Meteorological Drought in the Lake Urmia Basin Under Climate Change, Introducing the Precipitation Temperature Deciles Index. To begin with, what is meteorological drought? As you know, drought is an intrinsically complicated phenomenon and it does not have a single universal definition. Therefore, drought definition and quantification is a context-dependent matter. Meteorological drought can be defined as water deficiency driven by atmospheric conditions such as precipitation decline and temperature rise over a specific region and period of time. In other words, meteorological drought is governed by dry weather patterns which cannot be managed or controlled. It's important to realize that meteorological drought can instigate soil moisture deficit or agricultural drought, water resources shortage or hydrological drought, and eventually imbalance between water supply and demand or socioeconomic drought. That's why much effort has been devoted to quantifying and monitoring meteorological drought. Drought indices are the most common practical tool for quantifying and monitoring drought. A drought index is typically a single number that is computed from one or multiple drought-related variables. Among drought-related variables, it's well understood that precipitation and temperature play a pivotal role. Previous studies show that precipitation and temperature are correlated and do not behave independently. However, the interdependency between these two variables is generally overlooked in developing drought indices. In fact, the combined impacts of extreme precipitation temperature events can result in severe consequences. A low precipitation period, along with above average temperature, can exacerbate water shortages and drought conditions. Nevertheless, a methodology to systematically characterize meteorological drought based on the joint variability of precipitation temperature had not been developed. This study develops a bivariate index, the Precipitation Temperature Deciles Index or the PTDI, to characterize meteorological drought caused by the combined effects of precipitation temperature. Based on the PTDI, meteorological drought is defined as a period when precipitation is less than its long-term average and temperature is greater than its long-term average. To quantify this definition, or in other words, to put this definition into a mathematical framework, the probability that precipitation is less than or equal to a certain value and temperature is greater than a certain value is split into 10 parts or deciles. To determine drought conditions at any given time, this probability is calculated for precipitation and temperature values at that time, and the decile range into which the calculated probability falls is identified. If the probability of a pair of precipitation temperature values is less than 0.1, then this pair belongs to the first decile range, and either precipitation is very low or temperature is very high, or both. As a result, the first decile range is called extremely dry hot. On the other side, if the probability of a pair of precipitation temperature values is greater than 0.9, then this condition is designated extremely wet cold. Now the question is, how do we calculate the bivariate probability that precipitation is less than or equal to a certain value and temperature is greater than a certain value? This probability is equal to probability of precipitation minus the joint probability of precipitation and temperature. The probability of precipitation is calculated from gamma distribution and the joint probability of precipitation and temperature is calculated from copulas. A copula is a multivariate distribution function that couples the joint probability distribution of correlated variables to their individual distributions. We used the proposed drought index to predict how meteorological drought conditions would change under climate change in the Lake Urmia basin. Lake Urmia was one of the largest salt lakes on the earth at its original extent, but is facing severe desiccation now. Studies show that Lake Urmia shrinkage is triggered mainly by climatic changes, and the desiccation process is exacerbated by intense water extraction upstream of the lake. As a result, the survival of Lake Urmia is highly dependent on changes in future climatic changes and agricultural water withdrawal. Results suggest that the climate of the region is projected to shift toward drier, hotter conditions in the future. Moreover, the magnitude of climate-induced water deficit is projected to increase under future scenarios. According to the PTDI, the number of extremely dry hot months is projected to increase in the future. This condition is unfavorable for the revival of the endangered lake lake while maintaining the agricultural activities in the region. If you're interested in the results or the methodology of this research, I invite you to read the paper and leave comments below this video or contact me in case you have any question or idea. Many thanks for watching. Abbasian here. I'll see you in the next video.